All right. Hello, everyone. Welcome to the launch of Cloud Security Alliance of Washington, D.C. chapter monthly webinar series. My name is Uma Rajagopal. I am the assistant event coordinator for D.C. chapter. Bit about Cloud Security Alliance. It is for not-profit, vendor-neutral organization chartered to promote the use of best practices in providing security assurance within cloud computing. And it also providing education on how to use cloud computing to help secure other forms of computing. To that end, the DC chapter of Cloud Security Alliance serves the local CSA memberships, which includes a heavily regulated entities such as US governments, healthcare, and financial sectors. There are many ways to get involved with our local chapter, which I'll share it at the end of this talk. We are honored to have Ross Yang join us to kick off our webinar series. Ross, a little bit about Ross. Ross is CISO of Caterpillar Financial Services Corporation, co-host of CISO Tradecraft Podcast. Highly recommend the podcast if you are in the cyber leadership, and also creator of OWASP threat and safeguard matrix. He is going to be talking about how to secure an Adolescent cloud today. Don't we all need that to hear? A special thank you to our silver sponsors, Option Security, also supporting partner Leader Connect in supporting our local chapter as well as this webinar. To that end, Ross, welcome, and the floor is yours. Please take it away.
All right, thank you, Uma. Very nice to be here and join everyone today. Let me share my screen so everybody can see. And then, Uma, if you can just give me a thumbs up, or if you can just say it's good and you can see the screen and hear me okay?
See the screen, Ross, thank you.
All right, perfect. So I was thinking about clouds, and they're almost starting to become teenagers. And, you know, I don't know if anybody else has kids, but you start to realize that starts to be some of the most difficult times when you're raising a child and you're dealing with these adolescent youth. And now we're starting to deal with an adolescent cloud. So why are we talking about the cloud today? The first thing I would say is a cloud journey is inevitable for most companies. You know, we're seeing requirements in laws and regulations coming from countries saying you have to store the data in country. We're seeing it in Europe, we're seeing it in China. Not only that, but most organizations already have some type of cloud solution today. So you might be using public websites to send data out to some third-party company. So example, many people use Salesforce.com as a way to do customer relationship management. You might use GitHub to source code as a source code repository. And if all that wasn't happening, you know, and you're using other things like Intuit to put your loans or your financial information for tax time, you might just have pressure from your management coming in that says, hey, cloud is cheaper. I've read it in the Wall Street Journal. Can you get on that? And so there's pressure, there's expectations across organizations that we're a modern IT company, right? Nobody wants to be living in the days of mainframes anymore. We kind of want to get out of that. And if you are in those days, you're probably seeing things that are getting very expensive from a maintenance cost. Your ability to hire COBOL and Fortran developers isn't what it used to be. You know, people are starting to come with Go and Rust and Python and more modern programming languages, including JavaScript and .NET, which isn't really as much, but maybe there's some legacy work that you're still going to be moving into the cloud. And so you do what most companies do. You put out a vendor acquisition between 3 cloud providers. You're probably going to choose between Google Cloud, Microsoft Azure, and Amazon Web Services, or AWS. And when you do this, most organizations are probably going to select AWS. And the reason why is they have the lion's share of the market share. They have more services than anybody else. So it's very difficult to unseat them. However, we are seeing the industry choose other ones like Azure, particularly if you've been a huge Microsoft shop and you're getting some great discounts with Office 365 and SharePoint and all of the E5 licensing that you might get with Windows. But you may also find that if you adopt one, you slightly get into adopting a second or a third one before you even know it. So maybe your machine learning shop comes to you and says, Google just really has this fantastic image recognition software, and we would like to use that. Or your web application team chose AWS and they're using that, but your desktop side says licensing issues for Amazon are very expensive when we're trying to do Windows servers. And they would perhaps be able to save a lot more money by using Azure custom pricing. So if you didn't have enough difficulties just getting across multi-cloud, you might also be dealing with digital disruption, right? So we have more than one initiative happening in every organization. Certainly DevOps, Agile, Lean have been really big over the past few years, but we're also seeing a shift in a lot of the different technologies. Depending on your line of business and where you are, you may have to deal with Kubernetes and containers. You might also have a focus on running, no-ops or serverless, or you may just have a lot of buzzwords from AI, ML, blockchain, whatever it is that's hitting your organization as you're trying to deploy these things. It can be very difficult to see how everything integrates together and what do you want to do for best practices going forward. So as I started looking at this, you try to figure out what is it the cloud providers are recommending. Well, they have something called the AWS Well-Architected Framework, and the best practices are really overwhelming. You have to do things like reliability, you need cost optimization products, you need performance and that whole SRE type of focus of site reliability engineering. You need detective controls, you need protective controls, you need incident response. It's a lot, right? And if you were to try to go through this, it's basically like trying to map to the NIST cybersecurity functions. And there's just so many, it can typically dwarf an organization's resources as they try to do that. So how do we simplify this and take it up a level and make something that's achievable for organizations to go down? Well, AWS also came out with something called the 7 secure design principles for securing the cloud. And they are implement a strong identity foundation all the way through prepare for security events. And we are going to go through each of these in a little bit more detail where we can figure out what the basic levels are and what the advanced levels are. But this is a really important thing to think about for any organization. If someone were to say, what are the basics I need to do to keep the cloud secure? This is what Amazon and a lot of thought leaders are recommending. So how can we ensure these things exist when we're auditing organizations, when we're doing third-party reviews? Maybe we're using the Cloud Security Alliance CAIQ. We take that and we're looking for things like this when we assess different vendors, if you will. So let's start with the first one, implementing a strong identity foundation. What that means is access control, authorization, least privilege, and separation of duties. Any of these, how do I know this is who I expect this person to be? How do I know this person has the need and requirement to be there? And this is still a valid person. And historically, we use two things in an organization to deploy this. One is SAML, and this is the assertion markup language where we can do a single sign-on authentication approach. And think about it this way. Nobody wants to have to go and maintain 20 different passwords for 20 different sites. They want to go to all of these 20 sites and they want to use the same one that ties into their corporate password. And we want to have the corporate identity have a federated identity management system that says, okay, yes, this person has, authenticated in with both a password and something like a multi-factor authentication. Maybe they get a ping ID request to their phone, or they provide some token from a Google Authenticator, right? This is the basics. If you're not doing this with your third-party organizations, what happens is you find yourself in a place where, okay, the unique company stores some logins. Well, this person left the company. Who went through and checked to make sure that person's account was properly deleted? And if you have to do this across hundreds of cloud vendors, that's really hard to make sure every single one is removed, particularly if they have access to sensitive data. Maybe you're sending data over to a Experian or Equifax company to do FICO checks, right? If somebody left the company and still has access to pull up FICO scores from from customers, even though they're not an employee, that's something you really want to handle. So let's take a look and say that we got those two things in place. How do we go a step further and take it to a more advanced level of limiting AWS resources for applications? And we're going to see two different tools that are going to simplify the process. The first is Action Hero. And what it comes back to is this. AWS gives you tons of permissions, right? And if you think about it, EC2 servers, which are the elastic cloud compute servers where you typically store all your Linux servers or Windows servers in the cloud at a very basic level, allows hundreds of permissions. Now, just because a developer wants access to something like EC2 star, which is grant every permission for EC2s, doesn't mean that's appropriate to give out. So some of those permissions allow them to change the security groups, and that can be very problematic if you are trying to lock a lot of traffic down. They can also change whether they're encrypted, not encrypted, and a lot of things that you wouldn't want to give out, particularly if you're looking for things like tokens and things that provide some type of identity that you can impersonate. So what Action Hero does is think of it as a listener. You run your application and you run Action Hero in the background. And then what you want to do is fuzz your website. So you go through all the features, you click on all the buttons, and you see what permissions it actually requires. So if we see the example here of the only thing the app requires is S3 listing of buckets, well then why would I give it access to S3 star, which has 200 permissions instead of just the least privilege of list buckets? And another thing that really can be very powerful is this tool called Helium, which is a Python implementation of Selenium Grid. And if you've never heard of Selenium Grid, it's how you can do functional testing. So with just a couple commands, we can see we're starting a Chrome browser. We're going to type in a username and password, and then we're going to do some functionality tests on our github.com website. But what I want to show you is it's really easy to write functional tests with tools like Helium. And now if we have Action Hero in the back side, listening to all of the AWS permissions that you need, what you can do is take both of these together to really enumerate all the privileges an application needs. And this is a really powerful thing to enforce least privilege in the cloud. So it'll protect your organization when they're not using all these S3 permissions. And if your app ever becomes compromised, then you've removed those vulnerabilities because those access rights simply aren't there. Another thing that we're seeing is these YAML scripts are often very difficult to read by new developers, and it takes a lot to learn how to write them. And so they're taking shortcuts and allowing star access. Now, we're also seeing other tools like Policy Sentry that are trying to simplify this. So if we go back to a simple method of what we would have taught a developer in college is something like CRUD. And if you've never heard of CRUD, it stands for create, read, update, and delete. So it allows someone to put a very, very specific list of what the functions of this application need in terms of permissions. And then it transfers that knowledge over to a YAML script that your Terraform or other files can start to implement. So this is really powerful because it makes it very easy for a developer to look at this and write this out, as well as the security team to look at, okay, you just need these 2 permissions. Okay, that makes a lot more sense than, well, what does get parameter history really mean? Well, that's a little harder to understand from a policy audit perspective, if you will. The second fundamental that we really want to focus on in the cloud is enabling traceability. And what we mean by that is, okay, we've already granted some legitimate user access to our system. How do we know that that person isn't taking advantage of the application? Particularly if this is a customer, right? If customers can, perform any type of OWASP top 10 attack on your website, well, that could be very damaging if they could see other customer data, right? And so you want to be able to log those events. And there's a couple of functions that allow you to do this. There's CloudWatch, which allows you to log things like your EC2 servers. And then there's CloudTrail, which allows you to record AWS actions. And both of these are really important. So for developers, we often see them using 2 different types of things to log into a system. The first is a command line access, or CLI, command line interface, where they're going to open up a shell and then they're going to type in commands to authenticate in and then do things. And this is really how we want them to do it, because we can create files and infrastructure as code concepts to deploy things in a very repeatable fashion. But AWS also provides something called the console, which is the pretty web GUI when you log into the AWS web page. And this allows developers to have basically the same functionality. However, is it trackable? It is via CloudTrail, but typically when we have developers writing scripts, we want to have them go through a DevSecOps CI/CD pipeline. And this is where we can do our security test or quality assurance test and all those things where we would want to say, is this a good change? But if a developer can just go to the console and change a firewall rule and he skips all of those steps, well, where are we recording this? How are we making sure that happens in a good proven pattern? So we have to use things like CloudTrail to assess this. And after we get to those basic levels, what we want to do is look for what are some more advanced solutions where we can say, hey, these things don't look like they're configured well against best practices. And we're going to see Cloud Custodian, Scout Suite, and others to help with this. So the first one is, what do we need to look at? And within AWS, there's a lot of different types of things that could be very interesting. We can see secret values coming from the CLI. We can see things creating different function calls in Lambda. We can see how snapshots are called. And each of these things can be really important when we're looking at the logs to know what's happening in our environment. And Cloud Custodian allows us a way to create automated responses. So think of Cloud Custodian as the way you can have a Lambda job listen to certain events happening to your environment and then trigger a pre-programmed response. So if somebody creates a S3 bucket and makes it publicly accessible to the internet, you might want to know that. And this can do a variety of different functions. You can have the event just alert you and maybe trigger a notification. You could also have it turn that service off, right? And this could be a good action or a bad action, right? If it's a public website that we're deliberately hosting on S3, that could be very bad. But if it's a private website that somebody has allowed on a public web-facing server via S3, then that would be really important to block. So you'll want to tune this in and look through what's appropriate for your organization. Additionally, there's another tool that comes from, I believe it's the NCC group, called Scout Suite. And it will check all of the services in your AWS environment, compare those against the CIS controls and benchmarks from CI security. And this is a really easy thing that you could do or implement on a 30-day basis, where your second line or your cyber organization would just look once every 30 days to figure out, hey, what things appear to be misconfigured? If you have a security rule that says everything needs to use encryption at rest, we might see certain EC2 servers that don't have KMS, the key management solution, turned on to encrypt at rest. And that could be a finding you could go work with developers to police. And it really helps you identify how your external attack surface is evolving in the cloud. Another thing we have to think about if we've gone through logging events is how do we make sure we're getting the right events and security at various layers through an application. And what we mean by this is really exemplified in the Equifax attack, which is most organizations have a tool like Qualys or Nessus to scan the operating system and middlewares to make sure they're patched within their web applications. And that's great, right? We certainly don't want any bad versions of SSH open that are vulnerable to remote code execution. But if I'm running Apache Tomcat and I'm running, different types of libraries to host my web application, I need to scan those libraries too. And the way you can do this is by using something called a RASP solution, which is a runtime application self-protection tool. And if you take an agent of a RASP and you put it with an agent of a vuln management solution, now I can check my running web application to see if it's patched at the OS layer, the middleware layer, the application layers. And this is what you need to do to defend yourself, just like Equifax needed to defend themselves against the Apache Struts technique, where they had a vulnerable version of Struts library, which basically allowed a massive data breach and compromise. We also need to look for things to limit access. Our virtual private networks and VPCs, our security groups, our WAFs, any of these things that can limit the scope and access. And AWS provides something similar to Nessus or Qualys called AWS Inspector. And it will look through your AMIs, which are these machine images that you create. Think of it as a Linux server and scan it to say, is there a common vulnerability or exposure within this image? And so think of it as running a Nessus Qualys scan to say, okay, I'm not using the latest patches from Windows or Ubuntu. And you can actually build out a very scalable pipeline so that every time a new AMI image is published, you can tell if it has findings or not. And this can be really valuable because now you get to a way to push out your software as fast as possible. And if there's a vulnerability in the base image that your whole organization standardizes on, now you know that, and you don't have to flag it as findings for the 10,000 developers who use this one image. Because why are they going to fix something that's handled at a core infrastructure level across the entire company? And when we look at it and we try to get a runtime inventory that goes across all of the layers, here's an example of what you can use. You can use Qualys Asset Inventory, which will tell you about a particular asset, tell you the ports that are open, tell you if there's any vulnerabilities, and as well as Contrast. And Contrast or Screen or T-Cell, they're all different types of RASP products. I just chose this one because it had a flashy graphic where we could look and see, here's the libraries that are being used by this one particular application. And oh, by the way, you're on version 8.5.11 for Tomcat, which has 4 known vulnerabilities. And the latest version is version 9. So this is something where you'd want to understand where those teams need to patch and apply. And you can use this to score out different application teams and get real-time inventory listing. So if somebody comes in just like this week where they say, okay, we need to know all the applications that are running SolarWinds Orion because there's a massive vulnerability with this, Well, now I can just query between Qualys and Contrast to figure out who has those libraries and know which applications I need to remediate against by the findings from these two agents. Now, if we start to think about how do we automate the best practices of security, well, what we need to do is think about security becoming code, using this infrastructure as a service policy. And traditionally, you have very simple things like locking down S3 buckets, which is pretty much a standard these days in the cloud. But we need to think about what are other things we have to look at in our environment. And let's take a look at that. If we're building a custom web application, we need to scan that to figure out if there's vulnerabilities in our library. Now, we talked about how you could have a runtime agent do it, but you could also do it in a build pipeline through tools like Shift Left, where it'll say, hey, here's the vulnerabilities in your code. And it will also do things like a SAS scan, where we're checking our custom Java code to see if there's vulnerabilities in that, and in license checks. So maybe you're using open source licenses in a way that you shouldn't be using that. So how can we go ahead and identify that, particularly if we think that's going to be risky for our organization? In addition to checking out your custom code, we need to understand how our infrastructure code might be vulnerable. And this is where we defend against cloud misconfigurations. And there's a couple of free tools for this. Checkoff from Bridgecrew is really quite popular. So is TerraScan. Here's an example of Checkoff. And what it's going to do is check against the CIS benchmarks for AWS or Azure and identify if you have findings. Very, very simple tool to use. And it's helpful to know where you can secure your AWS infrastructure. Now, as we start to go deeper and we look at the principle number 5 of protecting data in transit and rest, most people have gone through the basics of we're going to get rid of SSL and only have TLS 1.2 or 1.3. We're going to use some type of encryption at rest, and AWS is probably KMS, but it could be Vormetric or some other tool. And then afterwards, we need to figure out how we protect data a little bit better through things like requiring WAFs, these web application firewalls, looking at VPC flow logs to figure out if there's spikes in our traffic, looking at guard duty alerts, which is essentially a data loss prevention tool, and checking AWS config, which would identify misconfigurations in AWS. But in addition to this, we have to look through not just web applications, but APIs or data that's being stored. Many places have a PCI requirement to encrypt all PAN data, essentially the important credit card data at rest. You also want to make sure that if you have a QA or test network, that data doesn't have PII data within it. So you need to check for those things and make sure they're tokenized or you're using test data. And AWS config allows many of that views. It can show which of your applications are encrypted, which ones have been rotating secrets, which ones have your WAFs implemented, if there's anything where you're getting data loss prevention alerts. And this can be just a quick way to ensure you're meeting compliance regulations for your organization. Now, if we're looking at how do we keep people away from data, we need to understand access. And we talked a little bit before on how we can use tools like Action Hero to enumerate just what you need. But sometimes we get backed into a different situation. And an example of this is, let's say your data science team says, hey, we need to get a new cloud account, and we don't really know what we're building yet. It's going to evolve, so we need admin everything, that admin star type access. Well, it's surprisingly more common than you think, and you don't want to be just a business blocker. So you say, okay, we're going to allow you to have admin access while you do a test proof of concept pilot for your system. And then later when you get ready to make that a production app, we're going to come back and revisit this to really lock it down, because we can't lose production data. But for a dev system, it makes sense to allow you very broad permissions. And so what we can use is AWS's Access Analyzer, and we can see what roles people are using, what functionality they're using, whether it's S3 buckets or Lambda functions. And we can see when was the last time that they used them. So if we're noticing the team hasn't used X permission in 90 days, we might have something that says, let's just remove that permission from them. They don't really need this access. And if they do, we can always, re-add it later. And this can be a way to start to restrict and limit the access. And this is a great way from avoiding the problems of one developer account being compromised and losing admin access to everything. So here, if that developer is somehow spearphished and he only has 20 permissions at that point in time, that's a lot better place to be in than losing access to 1,000 permissions. So as we start to think through this, there's a lot of things that can happen. Certainly events and security incidents is something that any large company is going to experience. You're going to have a security operations center set up. You're going to have an incident response team, but making sure those teams understand the cloud. And it's very different, right? The way you would image a laptop is very different than the way you would image data on an S3 bucket. And your teams need to have an understanding. So you might bring them into an AWS Solutions Architect exam after going through appropriate training to bring them up to speed. And you'll want to make sure that they have incident response guides that actually map to cloud processes, particularly if you have it not just for Amazon, but also for Azure. What's the process for each of these clouds so that they can take things and perform things like chain of custody and making sure that they didn't tamper with the data in unreasonable ways. So I'll send this PowerPoint out, but there's a couple of links on how to do this from AWS and the multi-cloud approach. So I'm going to take the time now to open up for questions. As Uma mentioned, I do have a podcast called CISO Tradecraft that I invite everybody to listen to. I also teach at SANS, and I'm very active on LinkedIn if you'd ever like to touch base and talk a little bit more.
All right. Thank you, Raz. It was really valuable. I was happy to see the mention of Fortran and mainframe languages. I myself, the developer on those, I used to have some backdoor course, no longer now. Great. Few questions pop up. So would you be able to answer a few of them, Raz?
Yeah. Happy to answer any questions from you or others.
Okay. So what are the key challenges that enterprise typically face while they're trying to transform into DevOps and cloud?
So one of the first things I think you're going to find is cost, right? If you have one budget that is just your traditional environment, and now you have to do that plus cloud, well, your cost may actually go up to double before you're fully able to transition to your second place. The second thing that I would say with cost that's really important is developers may not understand that they need to turn things off in a timely manner. So whereas if it was just my own VMware infrastructure running on this rack, I didn't really care. It was just a fixed cost. But if Amazon is billing me by the hour and I'm not working on something, probably best to turn it off over the weekend or after I leave work. So I think that's one big thing out there. And I think people just don't understand all of the ways things become a lot more open, right? So maybe before I had developers programming on a network that was within my network, and if they made misconfigurations, it was very internal. But if I'm on the cloud and I accidentally expose something as public, well, it can be very externally facing really quick.
Oh, sounds good. Yeah, cost is an important thing that we have to watch out for. So what about the cultural change? Why is it so difficult? And what is the best way enabling this culture shift towards DevOps and cloud?
So culture change is not something that happens overnight. There's a couple of ways that I've seen it happen. When I was in the federal government, what we used to do is free training, and we teach people how to use DevOps tools. And that brought a lot of people to come in and learn. And if you make it convenient for people, that can really change their mind on things. And you see this approach where you can provide these opportunities for people to mentor or emulate others. And then you kind of promote things where here's one team that really is doing well with the cloud, and you see it through some of their velocity and the ability to deploy multiple times per day. And then that can be something you can share with others, and they're like, oh, I'd like to get to that, right? So I think there's building communities of practice as a way to share this knowledge with others. I think having subject matter experts and very low cost or free training within your organization to really make this message go viral.
Yeah, that's important, really important. One other question that just popped up, what are the most common mistakes that enterprise typically see during this transformation?
So I think in this transformation, people will have bought the cloud before buying any security tools to audit or police the cloud, right? So if we go to this example where we mentioned that a data science team wants a brand new environment and they're just spinning things up, and they know how to massage data, which is great. But what they don't know is how to secure a server. So if they're not using, standardized AMIs from an organization, if they're not having checks against their infrastructure, Terraform or CloudFormation code, they may be creating very vulnerable instances, very broad permissions, and the security team may not actually have a tool to police the cloud up front. So making sure you almost have that set up so that you create a good environment from the beginning versus years of cleanup to go through.
Great. Thank you. Thank you for sharing your valuable insight with our community, Raz. And I don't see any other questions pop up. Any last words for us before we close this talk?
So what I would say is if anybody is interested in learning more about the cloud, the first thing I would do is start with something like the AWS Solutions Architect exam and certification. And you can take a lot of different training courses. A Cloud Guru is very popular, but there's quite a number of other sites. And then afterwards, use that to gain a base level knowledge of a cloud provider. Then think about what is it your organization needs to do to tie back to these secure principles that I mentioned. And as you put those two knowledge steps together, I think you're going to get into a good place.
Great. That's a valuable advice for us. All right. Thank you guys so much for your time today. And thanks once again for our sponsors, Custodian Security, as well as Leader Connect. Our hope this webinar was valuable for our listeners. Our next webinar is going to be on January 12th. We will learn more on how to secure SaaS applications. So you can sign up for this webinar and learn more about how to get involved with our DC chapter by visiting our website, cloudsecurityanalliance-dc.org. Please join our meetup and LinkedIn groups in the site and follow us on Twitter at Cloud CSA-DC. With that, we conclude our December webinar. And thank you, Ross, and happy holidays, everyone. And please stay safe. Thank you.
Thank you, Uma, and thank you, everyone, for listening.
Thank you.